Hey Thunder, congrats on the first. Okay, I think that thing's up and running. Okay. I want to do number 3 while it's still fresh on my mind, I think. You put that there. Hey, I'm not sure how to say that. Maybe I'll say Davey, unless you correct me. Welcome in. Hope you're doing well, Thunder. So these are some notes I was hurriedly taking during office hours a few hours ago this morning. I need to organize this better. Let's put this down here. Oh, yeah, I even tried to integrate this directly. It's a bit of a pain, you might say. I think I don't I think I don't think I'm gonna have to actually figure it out explicitly though for this homework though, thankfully. Okay. It's basically the same thing. Oop. Excuse me. It's basically the same thing as integrating 1 over 1 minus cosine theta. Like, you can ignore all the extra letters, but that's still an annoying integral to do, so... Integrate the imaginary numbers kind of like the area under the imaginary vector. Ooh. It's a good question. See, I forget. I don't think you've done multivariable calculus in general, right? Like, I'm not talking about imaginary numbers. Not at all? Okay. So, I'm probably gonna have to Google it, but let me start off by not talking about imaginary numbers, because imaginary numbers are basically, as you say, just like a vector. Like, they're nearly the same thing as just a two-dimensional integral in general, but when you get to higher dimensions, you kind of have more options. So I want to start by talking about like what the options are. So x, y, z. If you have some surface in 3D, that's like z equals, I don't know, 2 plus sine x times sine y. I'm just kind of inventing something that's going to give some kind of like wavy-ish surface, just to kind of give us something to talk about. Just pretend it looks kind of like a blanket elevated above the xy plane. So if you integrate, you can integrate and find the volume underneath this surface, which is like the exact analog of the area under the curve in regular like single variable calc. And And how that would look is just you do two integrals in a row. Let's say you want you want the volume underneath like the square of length 1. You'd have an integral from 0 to 1, 0 to 1, 2 plus sine x sine y dx dy. Okay, yeah. So when you learn about like multivariable calculus, that's like maybe not the first thing you learn, but that's kind of one of the first things you learn with like integration. And actually, yeah, I think this is common to learn, and it's common to get introduced to this earlier. But to be honest, I don't recall seeing double integrals often, if ever, with complex numbers. I'm not sure if they have a good interpretation, or maybe like a different No, I mean, you could do it. There's no reason you can't. Stooky, good morning, good morning. It is. Hope you're doing well. It's like, I think you could interpret it like you have two areas that are in a vector. It so like this gives you just one number out, like it's just a number like 4 or something. And you could do the same with complex numbers. It's just that now you'd have like a two-dimensional thing. It'll be like 4 plus 2i or something, and these would each independently represent their own volumes. I think that's what would happen. It's definitely true that if you do have the integral, or anytime you have an integral of well, that's the thing. It's like that's why it's hard to visualize this. If you have an integral of some, let's say you have a complex function f of z, where z is a complex number, you, as far as I know, you can always split them up into, like, this is a really common thing. We'll say, and we'll say z is equal to x plus iy. Maybe you can't always do this, but at least for a function where this is possible, you can split this function up into a real part and an imaginary part. Oh, this is already getting weird. If oh yeah, Fluffy, if f is analytic, sure. I'm just wondering if you could construct some imaginary or some function of a complex variable that can't be split up like this. I assume you can, but you always can, but I don't know. Can you split up like e to the z even, actually? I'm not sure that you could. I don't know if this is worth thinking too hard about. Actually, yes. Yeah, you can. Never mind. Sorry. Okay, this is not the point. Okay, so I don't know of a time that we're ever interested in the double integral of some function of a complex variable. And let's just say like from A to B, from C to D. A and B are the real parts, C and D are the imaginary parts. But if you were for some reason interested, you could always use this version of f and then use integral properties to split it up into two separate integrals. And I is just a coefficient, so it can come outside of the integral. And so that's what I mean with and so I guess, well, before I say that, so we now have a volume under the surface of the real part of f and a volume under the surface of the imaginary part of f. And so this is going to be some new complex number, and that's why I'm saying you get two separate volumes. Because f has a real part and an imaginary part, but we split it up in a way such that it's like just two real integrals. They're still separated because of this I in front, but yeah. Yeah, I mean, complex variables definitely have a lot of applications with fluid dynamics, so maybe if there is one, you know, that could be a good source for it. Usually with complex variables, we're way more interested in a different type of integral in multivariable calculus, and that's called a contour integral or a line integral, depending on your... Usually line integrals for real, contours for imaginary, but it's not like a big deal. And so rather than asking what we've done like in this box isn't particularly related to contours. You could do a similar thing once we have defined the contour integral. But double integrals and contour integrals are just kind of different. So actually, maybe I'll leave that top part there. Hey, Fenvox. Hope you're doing well. So in how a contour integral is different. So we were just we just drew this two-dimensional area, and we were asking for the volume under the surface inside this area. But there's a different thing that we can ask for, which is instead of a two-dimensional box, we can draw a one-dimensional line. It lives in three dimensions, but like a line is still ultimately like one-dimensional. It's a really hard thing to describe and to wrap your head around at first, but in the same exact way, you can ask for the area under the curve of this straight line along the x-axis. You can also ask for the area under the curve of this curvy line. And so I imagine it as like it looks like a curtain almost, but the top of the curtain is all wavy, and or even like the curtain itself is just like all like wavy, I guess. And so you can basically define whatever type of path you want, like a circle or just some squiggly line, and you can get the area underneath the surface of your squiggly line. You had a really good night's sleep, so you're in a good mood? Hell yeah. I went to bed late and woke up early, but I haven't been feeling it so far today, which is nice. Who has the best linear algebra videos except for 3 Blue 1 Brown? The only other ones that I've watched, actually I haven't watched 3 Blue 1 Browns to be honest, but the ones that I can speak to from personal experience are MIT OpenCourseWare. And well, let me get you the link. We're getting a recommendation for Khan Academy, which is probably good too. And Thunder, I'll get back to this in a second. I believe this is the one that I've watched. I'll put it in the Twitch chat too in case anyone is curious. String the one algebra, he is really good at teaching it. Okay, so the bottom of the curtain is wavy just because I am saying that we can define any arbitrary path that we want in the XY plane. Oh yeah, I do love some black pen, red pen. So yeah, and so it could represent like the path of a particle, like that the wavy line could represent the path of a particle as it travels through something. So like uh a physics example would be like if you have a positive test charge at, or just like a positive charge at the origin. It's a common question to ask, if we have some other positive charge out here and we make it follow like this path and it ends up here, how much work have we done against this positive field in the middle? It turns out like you don't actually need contour integrals for this, but this is what you would start with, and then you would prove that you don't actually need it. Clonk. It is much wiser to take advice than to give it. Ooh, that's a good fortune. I was peeping on your art. I hope it went well. So yeah, if I call this curve C, like we could in theory like parameterize it and get an actual like formula, but we would denote an integral like this as the integral over the path C of f of z dz. I think dz. And then you can do the same thing with splitting up into a real part and an imaginary part. So with the complex numbers, you can always like, or you can usually like recover geometric meaning by making it into a typical real valued situation. You done so much probability the last couple of days. I'm dizzy. Ooh, probability is cool though. I just learned some really cool stuff about probability in my a class I'm taking about modeling cancer. What is this creepy music in my Scooby-Doo scene? Yeah, it's I actually I quite like the this artist. That was a weird way to phrase it, like overly fancy. Um but yeah, the artist's name is Radar, and it's kind of like Halloweeny music. Like dark synthwave, I think it is the name of it. That's such a good emote. Um, you have a technical interview at a quant fund next week. Ooh, good luck. Hope it goes well. Yeah, I haven't been able to show it on stream just because I like PDEs has been taking up like, or it's been like sucking all the air out of the room. But we're doing like stochastic models for cancer. Hey, famished. And so if Zach pops in, I was hoping to like show him something cool that we just learned yesterday, but I'll say no. Hey, color cone. Let me see. Yeah, so oh man, there's been a bunch of cool stuff we've been doing in this class. Oh no, you did not, but thank you. I was thinking about smoking yesterday, but I didn't really feel like it. Happy 421. I smoke like every few months. It's not a frequent thing. It's been a tradition for me after my last final to go and pick up some weed. So you don't access to materials for my master's degree at a math PhD student who works in healthcare. Did a whole class proportion engineering in my SC class. Oh, that'd be that sounds sick. Yeah, I'm saving everything I possibly can for my classes. So I don't want to end up in a spot like that. Okay, what's a cool thing that I can show? Okay, yeah, I think this is a thing we did that I thought was really cool. I mean, I don't think it's a weird combo at all because you need to relax somehow after your finals. Really? Oh wait, I think I heard that about Erdish, if that's how you pronounce it. Coffee, that's fair. Okay, so actually, I one second. Okay, uh, this is about a. It's called a pure birth process, which sounds kind of hippy dippy, like, like a tub birth or something. But I don't mean that. It's about like a model for cells. So one of the big things about cancer cells is they kind of don't really die. They lack the mechanism that uh that cells normally have to self-destruct called apoptosis. And that's a generalization. It might not be like strictly true or something. I'm not a biologist, but they're generally like super long-lived. Um, oh, that's right. You've been learning cell biology, Alex. You probably know better than me. So for cancer cells, it's like oh, I messed that up. uh, one second. Okay. Um, They bet he could quit amphetamines for a month. He won it and instantly went back on them, so the mathematics has been set back a month. Oh, I think I've heard that. Yeah. So this is like a fundamental like building block you might use to model like the number of cancer cells, and but we're doing continuous time for this. So we're going to define a random variable xt, which is the number of cancer cells at time t. You had your first oral exam? Ooh, how'd it go? And we're going to define A, which is birth rate per cell in Morn. During a small time interval delta t, Um, oh, I need to define one more thing. Wait, no, I don't. uh, no, I will define one more thing. GBM. What is GBM? I'm gonna define a function p sub n of t. Yeah, it's not far off from a Poisson process. Geometric Brownian motion. I didn't know that. I never heard of that. Uh, this is small p, like lowercase p, is equal to capital P for probability that x sub t is equal to some integer n. I guess natural number. Really got a bit cooked on the last question. Didn't even know that chapter was subject to the examination. Oh no! Especially for an oral exam, that'd be so terrifying. Hopefully you still did well overall. I was just at the outsiders for my PDEs class, and the TA said that the professor was considering for the final making it an oral exam where each student goes up to the board and he chooses a random homework problem. And you have to solve it on the spot. And apparently he did not decide to go with that, but that would have been terrifying. Use GBM all the time in finance for modeling. Stats can't take on negative prices. Ooh, that's cool. Yeah, it depends on which homework problem you get, but that's still nerve-wracking. Okay, so during a small time interval delta t, you can make delta t small enough so that only one event can happen at a time. Um, Either one birth happens or division. The probability of that is NA delta t. So N for the current number of cells, A for the birth rate per cell, and delta t for the interval time. Or nothing happens, which is 1 minus that probability. Well, there's a lot of homework questions, though. The teacher can curve the grade in real time. Can he unship my pants in real time? Okay, and so we can set up an equation for p sub n of t plus delta t. And so either one birth happens. So if we have n at t plus delta t, and we know that a birth had just happened, it means we just had n minus 1 many cells. So we're going to take the probability that a birth happens with n minus 1 many cells. Well, I guess it's that. Wait, it's probability of getting to n minus 1 many cells times the probability of them giving birth again. And then if nothing happens, it's probability of getting to n many cells times the probability of nothing happening in the next time interval. You hated oral exams? Oh, you sounded nervous that takes your grade down? That cannot be a valid criticism. Oh my god. You were presenting in 10 minutes, that took you 2 classes? Oh, you've gotten it? That's a terrible, terrible learning environment. Okay, the trick with this equation is this Pn of t, you can subtract it to the other side. And then you can divide each side by delta t. And then you can take the limit as delta t goes to 0, because this is valid for small t, or small delta t. And this is the limit definition of a derivative. And there's no delta t's on the right side, so it's not going to change anything. So this becomes a differential equation. There is a little like trick here. Like it's valid for n greater than or equal to 0 if you define p minus 1 of t as 0. This is for my class about cancer modeling. So we're going over stochastic processes. And so I'm just sharing notes from a class because I thought it was cool, and I haven't been able to talk about it on stream. The thing that I thought was really cool with this is that we're now going to use a probability generating function. So you have to pull it out of your ass, but the probability generating function for a function x, or a random variable x. Yeah, exactly, Benbox, yeah. Is g sub x of s comma t. It's going to be a power series in S, basically, with p sub n as the coefficients. Jisun, sorry, it'll take me a little too long to explain everything from the beginning. It's all there on YouTube, though, if you want to go back and listen to it. I'll quickly say, what I'm talking about is a pure birth. I keep doing that. Oh my god. Okay, it's a pure birth process with continuous time, and so what I'm talking about is the context we're using it in is to model the number of cancer cells at a time t, basically, using randomness. And so just by defining like a parameter for the birth rate of each cell A, we can derive a differential equation for the probability that there's 0 cells at any time, 1 cell at any time, 2 cells, 3 cells, 4 cells, as many cells as you want. And so that's the differential equation that I got here, and we're about to solve the differential equation using generating functions. So the reason this generating function is helpful is that you can always recover. The thing we want is this p sub n of t. You want 0? Yeah, I mean, that's true. Yeah, I guess I should say that that's what p sub n of t is. It's you fix the number of cancer cells, and that's in p sub n gives you the probability of that number at any time. And so this generating function is cool because you can always recover p sub n for a particular n. For Harry Spotter 8, I'm super hyped. You can do that. So like the easiest one to get is p sub 0. That's going to be g sub x of 0 comma t, because you just plug in 0 for all these s's, and the only one that survives is p sub 0. If you want to say p sub 1, you take a partial derivative with respect to s, and then you plug in 0. And so on like that. You do get an n factorial out front because of the derivatives that we're taking. But that's how you can always recover your individual p sub n's. So yeah, we want to use this generating function to do something helpful. And so we're going to take this differential equation and make it look like this. So what I'm going to do is multiply each side by s to the n. And then secondarily, I'm going to sum it over, I'm going to sum all these different equations over n. So what we end up with is sum from n equals 0, dpn dt s to the n is equal to sum n equals 0 to infinity. I'll split up into two different summations on the right side. Okay. And so now we want to think about how each of these individual pieces looks like in terms of g. So on the left side here, this is just the partial derivative of g with respect to time. So that is equal to this term here. We want to mess with the indexing here. P sub -1 is 0, so we can freely start this series from 1. The a out front. And then I'm going to make the series start back from 0 by doing a change of variables. So it becomes n pn. This to the n plus 1. Ooh, wait. Yes? That's not quite right, though. Oh, no, yes. And then I'm going to bring two of these s's outside of the summation. As squared as n p n of t s to the n minus 1. And this, let me bring it closer for comparison. This, well, I guess just this piece, is the partial derivative of g with respect to s. So we get as squared dgx ds. Suhas, if you are free, can you give me your thoughts on some design principles? I have like rules of thumb. You can try me. I want to get through this little explanation. I'm almost at the end of it though. Okay, and then we can do the same trick on this thing. This one's actually a little bit easier. We just take one of the s's and put it out front, and it'll be the same. It'll just be as times the partial of g. And then I'll just make it look a little prettier. So we get a PDE out of this that it's possible to solve. It's just a transport equation. We do have an initial condition. So g sub x of s comma 0 at time 0. We start with 0 cancer cells. So p0 of 0 is 1, and pn of 0 is 0 for n greater than or equal to 1. So in order to make g of s comma 0 equal to just 1, well, I guess I just said it. g of s0 is equal to 1. There's no s's involved because we just want p0. And so we just been using Mathematica to solve these, so I couldn't tell you. There's a general way to solve this type of PDE, but I don't know it. But yeah, using Mathematica, you get... Oh, wait. I'm sorry. I got my initial condition mixed up with another thing. If you start with 0, you're never going to have any because they only... in this process, we're assuming they only produce by division and we're not including mutation. If we included mutation, or if we were only thinking about mutation, we would have P0 of 0 is 1. But here we're going to start with some initial population M. So P sub M of 0 is 1. P sub N of 0 is 0 for N not equal to M. So that means the initial condition is going to be S to the M with a 1 in front. Okay, then when you solve this PDE, you get a pretty clean looking solution. To the minus M. And so with the formulas that we had up here, we can recover any piece of N we want from this thing. You can also calculate things like expected value directly from the generating function. Same with the variance. There's actually a formula for the nth moment. I'm having an nth moment right now. It's g sub x. I guess, yeah, okay. I guess I'm gonna use k. The kth derivative of 1. I guess s equals 1. So you can get the mean and variance from that. Hey, Anchu, I'm doing good. How about you? Visiting how many random mutations occur in cells every day? Yeah, and like it's really cool. Like it's wild how you can make the like for cancer specific mutations, you can show how like even though it's super unlikely for cancer causing mutation to happen, humans live for long enough that like they still build up over time. And we can create math that like models that. Okay, so let me read what you're saying. Function over everything. Performance is the only metrics. Comfort is the default. You only sacrifice it when the payoff justifies it. 2 pass. AK-47 simple, brutal, does one job perfectly, or M16 modular, built to last. The tool should disappear, only the output should remain. It's just very like purpose dependent, I guess. Like for things in my daily life, I don't necessarily want functionality over everything else. If something's like if something does a job perfectly but it's annoying to use, I don't want to use it. But yeah, so I'd never seen probability generating functions before, but I thought it was so cool how we can use them to get like we could solve this ODE iteratively if we wanted to and hope that we can find a pattern. But for more complex situations, that becomes really untenable. Uh, and these PGFs give like a way that you can get kind of one clean PDE out. And sometimes the solutions to those can get pretty messy pretty quick too. But like you can do everything in just one swoop. Uh, how about this? Like, for my stream, uh, if there's some program that was like that, like created that chat window up there that was amazing and worked perfectly, but I have to separately open up a program every time that I stream, I wouldn't use it because that's a pain to do, and I already have other things I have to open up every time I stream. So like, convenience is really a big thing too. Recently some complex problems on vector algebra. Ooh, that's cool. Anshu. Like, I'm confused by like, what are your two like rules then? Because the individual sentences you put like sometimes agree with each other and sometimes contradict. So I'm not sure like. I don't know. So like, modular doesn't necessarily like mean that to me. Like I don't know. It seems um. I don't get how your metaphor with like AK-47 and M16 relate to functionality versus convenience. I guess. But yeah, and so probably journey functions are really cool. And the other thing that we just learned about yesterday that I want to show to Zach because I'm curious if he's seen it before. Um, is the Laplace transform, but not the one that I've learned about. Um, there is a Laplace transform of a random variable. Discrete or continuous, it works the same. The Laplace transform of some random variable x is going to be a function of theta, which is just some parameter, is the expected value of e to the minus theta x, capital X. And so if x is continuous, depending on its domain, you get something that looks a lot like just the regular Laplace transform. Um, if x is discrete, you get a finite sum. But I thought it was really cool to see like there's a probability version of the Laplace transform, and it's nearly the same thing. If you do it for like an exponential distribution, like it's literally the exact same thing as the Laplace transform of an exponential function. Like you get an integral from 0 to infinity, e to the minus theta x, lambda e to the lambda x minus dx. And if you do that integration, which isn't terribly difficult, you get lambda over lambda plus theta. Hey Rex, say hello to others. You have a happier day. That's nice. Good example is Linux. You can use whatever graphical user interface you want. KDE, VS Code. You can use whatever plugins and all that. And them. Better question would be, what do you think are the most important things like design principles? Uh, I mean, I guess function and convenience are the two like big things that there's usually like a trade-off. Hello, Rex. There's usually like a trade-off. Like more functionality is less convenience, more convenience is less functionality. But I guess that's kind of, I guess we're probably not too far off from what each other are saying. But yeah, the AK-47 versus M16 thing isn't quite expressing that in my mind, at least. After your lover has gone, you will still have peanut butter? That's such a weird fortune. Oh my god. Everyone should be happy to have me as a friend. I am your stomach. Well, it's okay, Fembox, because you can always have peanut butter, I guess. I know of the inverse Laplace transform. Is there a reverse Laplace transform? When I Google reverse Laplace transform, I'm just seeing inverse. They're kind of difficult to calculate, but I learned about them during my complex analysis class. Ooh, I vote orange juice personally. More math, less peanut butter. Okay. But yeah, I guess the lesson is stochastic processes are kind of sick, and I'm bummed that back in fall there's a class on stochastic processes. There's like a series of classes, but I missed out on the first one, and the next classes in the series had the first one as a prerequisite. So I'm bummed that I missed out on the entire series because I couldn't take it in fall. You master linear equations in one variable? Hell yeah, famished. Pretty sure it's a prank. When a fortune cookie, it said, the world will be destroyed in your hands. Use them wise. Oh my god. Yeah, that must be a prank. Otherwise, I just to be safe though, Suez, I'm gonna start being super nice to you, like, because what if it's true? I want to be on your good side. You'd be wise to keep your eyes wide open at all times. Okay. Orange juice greater than apple juice? I agree. I like apple juice. It's just they usually add way too much sugar. Orange juice has the same thing, but like it feels a little more balanced at least when they do overload it with sugar. I'm not a big grape juice person. White grape juice is nice, I guess. Your equation, two variables and functions? Hell yeah. Okay, that's what I want to share about stochastic processes, I guess. We'll go back to PDEs. Inverse? Okay, yeah, I've seen inverse. It's kind of crazy how you have to calculate it with the contour integral. Spicy V8? That sounds gross. I had never heard of that. Spicy hot vegetable juice. Maybe that'd be okay. I guess this base looks like salsa. I guess that's blended more. I accidentally stepped on an ant. I buried it inside a flower pot and stood there in silence. Wow. It's very respectful. It's yummy. I'm kind of warming up to the idea that it could be good, but I would be suspicious. I never had V8. I remember seeing the commercials though, and it's always like should have had a V8, and then they like smack you in the forehead. Okay. Um Pretty sure you're not going to destroy the world. Well, thank you for not destroying the world, Suhas. I do live here, so I appreciate you not. It looks everything but yummy. Used to drink the energy drink version. They had an energy drink? Huh. That's okay, now that's gotta be disgusting. I think energy drinks in general are disgusting. Wow, they did. I want to see the ingredient list. You get to monsters and energy drinks. Pear ginger? Oh, that actually sounds good. All right, guys, this is the sponsored segment. Oh, it's been discontinued. Where's the ingredients? Come on. Okay, fine. Keep your secrets. You did to monsters and energy drinks, now it's coffee. That's a lot healthier. Coffee doesn't work on you? Really? I've heard like some people are like kind of immune to caffeine. I wonder if you're one of those people, Cold Gold. Why do I think energy drinks are disgusting? I hate the way they taste, and I hate that they have way too much caffeine, like an unhealthy amount. If you drink more than one, and a lot of people do drink more than one. It's good to you up to a point, but I think I don't know if it's the FDA or the UK's, what is it called, NIH or whatever. There's like a recommended like 300 milligram maximum per day. NHS, right? Thanks, G-Son. NH is an American thing. I forgot. How many spoons? Oh, if like your typical cup of coffee, just with like grocery store coffee, is like 60 to 100. So if you're just drinking regular coffee, you're fine as long as you're not drinking like 5 cups or whatever. $10, 100%. I would make you a coffee. You just haven't had good coffee. Um, yeah, depending on how you brew it, you can get a lot more caffeine out. Um, the way that I brew coffee, it can have up to like 180 milligrams even. I'd prefer it not to. I'd rather have coffee have less caffeine. Um, but when you do like the fancy stuff with like a nice like kettle and stuff, you just like extract more out of your coffee. Um, and so you get more caffeine out of it too. But no, like I don't know this, but I've heard that like people with like ADD or something tend to not be affected by caffeine, or at least not in the same way. And so I think there are like genetic differences in how people process. I don't know if ADD is a genetic thing, but I think that there are genetic differences in how people process caffeine. It's 7 a.m. there and you're awake? Oh my god. You should make one. Do I have space age? I don't think so. I'm thinking of the Factorial DLC, which I do have that, but I assume you're talking about something else. Oh, you know, Australia has so many amazing cafes too. Australia is a huge, like, specialty coffee country. Why not take caffeine? Oh, I mean, for me personally, I love the taste of coffee. I wish it didn't have caffeine in it at all, or at least a very small amount. I'd rather not uh consume caffeine on a daily basis. Uh, in the original game, you could not go to other planets, but in the DLC they released maybe like a year and a half ago now, you can. Yeah, decaf, like decaf is kind of like not popular and it affects the taste. But if decaf was in a better place, I would prefer decaf. My mother knows a lot of coffee snobs here. It's fair enough. Australia's always a like. There are actual there's multiple different coffee competitions that are international, and Australia's always a big country in those. Okay, yeah, I do have the DLC. Yes, I wasn't sure if that's what you're talking about. I assume Space Age was something else when you said that. Yes, some roasteries do called like cuppings, which is a coffee tasting. Living that, people do see a fair amount of people who are serious about brewing. True, yeah, that is like classic math person. Being into coffee. Yeah, exactly, Suhas. Okay, I'm what I'm trying to do is translate these notes I was hurriedly taking during office hours into actual math. Yeah, it's kind of an awkward name for it, but they're called cuppings. um, it like cupping is a method of brewing a coffee, and so it's a really like simple one that's easy to do. So when you want to taste a bunch of different of coffees, you line them all up in a row and you cup all of them, and so they call the entire tasting a cupping. Yeah, it is awkward. Including our resident celebrity math guy who is seen regularly with a huge packet of coffee. Ooh. What do I want to explain to us? Wait, this is for part 3. I want to. Yeah, who is the celebrity math guy? Explain my entire life story. I'd rather not do that. But I respect the attempt. Okay. Uh, these are the notes that I want to translate. So, let u of r naught e to the I theta naught equal m. Just giving a name to the point where this happens. For Dr. Gold's, oh, true, yeah. My M, I feel like my M looks like a weird mu. That's too big though. Okay, that's more M-like. No, I'm not. He has offered a long time ago. I didn't follow up on it because I'm not a very talkative person. I feel like I wouldn't do well on a podcast. Um. Oh, I forgot that you went on there. No, I don't. I just don't feel like I have like much to say about anything. And if you're going to be on a podcast, you should have something to say. Yes, so that's fair. There's some things about my life that I don't mind sharing at all. Um, I don't know if I would ever want to like just like tell my life story though. I don't know. Oh, I think that's a typo. Uh, I've heard that we can just ignore this part. I should have said the part that I'm working on right now is just the first sentence because this is really three problems in one. So this part up here is just the first sentence. I do know the answer for the last part here though. It is false, and that's the next thing that I'm gonna like write up. Yeah, apparently the professor just like hurriedly types these homeworks out the morning that they're supposed to like come out. So they're not always like perfectly phrased. Field facts and knowledge based podcasts can't stand opinions. That's kind of tricky to di- di- differentiate between them in practice. I feel like, but I can appreciate that. Can't stand your opinions. That's true. I do listen to some like news podcasts, but the news is just kind of a bummer. So I sometimes have to like take a break from it. Started grinding your own beans again a couple of weeks ago. Oh yeah, that's a huge step up from pre-ground. Um, I'm never frustrated by having to write my process unless they want excruciating detail, or they're asking me to do something that's like super long that I don't want to do. But I I think if you can't express your understanding to someone else, then you probably don't understand that thing. But if you have ADHD, it's a little bit different. The old British ladies have started picketing outside of the U.S. military base again in like mood. Yep, it's fair. We are gonna note. Oops, 1/2 pi. Uh, Pizza bar. Wait, should I be including the 2 pi in my definition? Hmm. Yeah, so I guess that depends on the context. Um, I think sorry, I just realized that I said something slightly wrong. Or I might have done something. Okay. Uh, like what? I mean, just getting the right answer in a math problem doesn't mean that you fully understand it. Like, I often have like gut feelings with math problems about what the answer should be, and I have a decent percentage of being well. I mean, I don't know. And even if my gut feeling is right, it doesn't mean that I actually understand the problem. I guess. Rate does not go point A to point B. A is a prime number. That's the reason I can do this. Yeah, but like if you can't communicate the things that you're doing to other people, then that's a problem. Like, or at least you're only ever going to do math for your own entertainment. Like being able to communicate your math to someone else, I think, is an important part of like. I mean, it doesn't have to be, but I in my opinion, it's a good thing to be good at communicating your math to others. I mean, for mental math, you could do it if you wanted to, or like you could communicate it to other people if you wanted to, but I don't know. But um, well, that's another thing where it depends on your context. Where like if you're in a calculus class, you shouldn't need to justify why 2 + 2 = 4, but you do need to justify like when using the fundamental theorem of calculus or something. Oh yeah, I'm with you there. I don't think you should have to memorize things for math class. Oh. Memorizing stuff is dumb. Okay. Yeah. No worries, Fembox. I, oh my gosh. I've been meaning to do it at some point. I'm gonna have to do it sooner rather than later. But for the final project for that class, we're gonna have to take an academic paper about mathematical oncology, it's called, and kind of like take it one step further, like modify the thing that they did and do something new. And so she's or the professor like gave a bunch of example papers we could use that would be good like candidates, and I've been meaning to like go through those and try and figure out what looks interesting. So I don't know when I'll do that, but hopefully I'll do that on stream at some point. Oh yeah, I got that too, Suhas. I do want to uh check the value of this integral. Yeah, I the bit I've learned of it so far is really amazing. Uh, and I hope that I learn more about it. Well, I will learn more about it. Oh, I thought that the textbook was about the cells of monsters, and I was like, um, wow, I didn't know that we studied monster cells, but no, the book itself is a monster, if with how big it is. Is that the actual fact for California? For California? I don't know what you mean about California. Um, yeah, there was this really cool talk that a guest lecture in my mathematical biology class last quarter, just like maybe two months ago, did. Oh no, it's not the actual California flag. It says New California Republic. It's from Fallout, like the Fallout games, and the bear has two heads because it's mutated. Um, but yeah, that he presented it on a paper that he wrote, where he modeled, um, shoot, let me actually just grab my notebook. I don't think I took very good notes on it, but I think I took some notes on it. Okay, yeah. Of chronic, he modeled chronic hepatitis B. Um, oh, my notes are so sparse, but it lives in the liver, and all right, see you, Jisun. Good luck with your exam. AI talking skull inspired by servo skull. Ooh, that's cool, Suas. Um, he modeled chronic hepatitis B, and he had and he figured out the relationship between the number of like hepatitis B cells in the liver and the actual cellular dynamics for where how the virus takes over cells and makes it produce the virus's RNA. He related like the macroscopic, or I guess like the larger scale cell behavior to the smaller scale inside of each particular cell behavior, all in one like set of differential equations. And I wish I wasn't able to find his paper. I don't think, or at least I probably could find it, but yeah, it was really cool how the cellular biology, you could just translate it into differential equations. And yeah, I honestly I wish they sent out the PowerPoint because I'd be able to explain it a lot better. But I didn't take very good notes because I was trying to keep up with what he was saying. Do you think math's needed for computer science? Some math is needed for computer science. You are asking a lot of random questions. Yeah, but that's okay. It's part of streaming. Why doesn't Wolfram Alpha get 1 here? Oh, it's 1 minus r squared. And then we should get 1. Or 2 pi, same thing. Okay, okay, so what are we doing? We're letting the particular point where u achieves the maximum be that r naught comma theta naught. And then we're going to consider u r0 I theta 0 minus m equals 0. On u, we're going to use the integral definition. On m, we're going to remember that this thing is just 1, so we can freely multiply this by m. Or freely multiply m by that. Oh, yeah, Destin, like, he said that he has gone through it himself, which is, like, why he was interested in it. It does not sound fun from how he described it. No Disease sounds fun, but that one especially did not sound fun. Oh, wait. Oh, okay, so I guess I was wondering if we multiply m by the general version of this formula, but we need to multiply it by this same thing. And I think it's still true that, yeah, it's still 1 for any particular choice of r and theta. So interesting. Okay, so have you thought about machine learning for legislative policies? Um, I haven't thought about myself, but I actually went to a talk, maybe 4 months ago now, from a researcher at UCLA who was doing that exact thing, and what she was doing was so cool and gives me hope for machine learning doing good in the world. Oh, I'm sorry, not UCLA, USC. Let me bring her up. Yeah, okay, so this person. Um, I went to a talk that she did, Phoebe Vianos. And maybe it's the publications will be the interesting thing to see here. No cited paper. So, learning optimal and fair decision trees for non-discriminative decision making. I assume this is decision making in like a public policy setting. Socially sensitive decision making to decide who to admit into a degree program or to prioritize individuals for public housing. So yeah, the talk that I went to was specifically about prioritizing people for public housing. Oh, I haven't watched Friends. Is that Jennifer Aniston? No, never mind. You know, they do look kind of similar. Like the hair isn't quite the same color, but nearly. So yeah, after I went to that talk, she became like an academic, like I guess like role model or role model for me almost. Like if I did do research, I'd want it to be stuff like this. These automated tools may result in discriminated decision making in the sense that they may treat individuals unfairly or unequally based on membership to a category or a minority, resulting in disparate treatment or disparate impact and violating both moral and ethical standards. So we have when the training data set itself is biased. It may also happen when the training data set is unbiased if the errors made by the system affect individuals belonging to a category or minority differently. If misclassification rates are higher for blacks than for whites. Okay. Yeah, so this is super cool, I think. If I had to give a talk, what would it be? I wouldn't be able to give a talk at like her level, but I actually am going to give a talk. Oh shoot, sometime next month, and I need to get ready for it. But on a friend's stream, um, and I already have my topic chosen out. I need to just like flush out how exactly I'm going to do it, but it's going to be about the modeling of the spread of disease. Um, you're really into politics, but not like a fanatic. Yeah, that's fair. Like I'm kind of the same way. Like I need to take a break from it every now and again, but I like being aware of what's happening. I usually try not to talk about it, to be honest, because it's just kind of depressing. If you're an expert in any math, pure or applied, what would it be on? Ooh. If a genie just magically grants me the knowledge, I would probably choose PDEs because they're so freaking difficult. If it's something that I'm going to study myself, though, and have to actually earn, I go with like mathematical oncology or mathematical biology, I guess. AI algorithm trained on police data set is more likely. Oh yeah, so that's just a generally true thing. If your data set is biased, then so will your AI. So that's not surprising, I guess. Okay, so what's up with this? Oh, yeah. So maybe let's not go there. That's getting. I mean, we're already into the depressing part of politics. That's getting even more depressing, though. One minus r naught squared minus two r naught cosine theta naught minus t plus r naught squared, and then f of e to the it minus m dt equals 0. Based on police data, that's way too dangerous. I assume there's some like public records that are available, but yeah, uh, that's true. If they're like, it's probably with publicly available data. I would bet. The toughest unit in math, according to me personally, partial differential equations. Um, it's a class I'm taking right now. It's the hardest class I've taken in my life, and it's funny because just a month ago, I thought I was taking the hardest class I would ever have to take, which was asymptotic analysis, but I wish I was back in that class now. Okay, so this chunk here is not equal to 0, which means this chunk here is equal to 0. So we've just shown that f of e to the it is equal to m, which means f is a constant. Sure, a fully trained, at least 5 billion parameter AI in the future would be the GOAT as a politician. I mean, maybe we just need to know where AI goes. That it's kind of funny because that exact thing has happened in like Fallout, where you stumble across a computer that was like the mayor of a city, and it thinks like the city's been nuked and it's destroyed and ruined, but the computer is still going and it thinks it's still like doing its job. We're like 5 trillion. Yeah, how many parameters do you need to be an AI president? 5 trillion is probably reasonable. Can run 5 billion model on my computer. Wow, that's crazy. I have not beaten Fallout 4. I'm a Fallout 4 hater. I played a bunch of Fallout 3, Fallout New Vegas, Fallout 76. I've beaten Fallout 1. I've beaten Fallout 2. Um, I have not beaten Fallout 4 because I don't like it. Democracy 4, I haven't heard of that one. You took easy classes like convexity theory and Lebesgue integration during my master's program. I mean, I doubt those are easy either. Like Lebesgue integration? Galicia theory? I never heard of that. It's not a typo for Galois theory, like an autocorrect? Galicia theory? Okay, it is Galois. Okay. So my computer specs. Ooh. I made a command for this because people had asked me. I don't have a very good computer. Uh, those are the specs that I could easily find on my computer though. Skyrim. I played a tiny bit. I haven't gotten very far in Skyrim. Hey Raven. Yeah, my computer is really old. So like 2 billion. Okay. Honestly, for this PDEs class, I've been considering switching into the lower level like masters version of the PDEs class. I'm sticking with this harder one because I think the tests aren't going to be as hard as the homework, because the homework is brutally hard. But I'm just crossing my fingers that I don't blank out when it comes to the tests for this class. It's better than yours. Oh, sorry. I call my computer a toaster because it can. I like it's just I can see it performing worse and worse for the games that I like to play. Yeah, I think that's true. Just this professor is kind of wild though. I do think that's going to be true for this professor too, but I don't. He's kind of a wild card. He pulled a pop quiz on us yesterday. When our first, and we're gonna have two midterms in the class. The first midterm is next Wednesday, and he pulled a pop quiz on us yesterday. Thankfully those questions, it was only two questions, and they were really easy. Like the first question was literally, what is the definition of the Laplacian? And give an example of a harmonic function. The second question was one that was on the homework, and that was a pretty short one. But it's still like I when I walked into the classroom and just saw him, like I got there at the last minute, and so I saw him walking around the room handing out tests. Like, what the hell is happening? Did I get the dates mixed up? Is the midterm happening? The toaster technically Turing complete. That's funny, Suhas. Raven, not a very good reason. I just want to learn more math. There's not really a particular job that I want. So we're almost done with the first part of this problem. We know what f is in general now. It's just a constant m. So now we can plug into the general definition for u. This is still working. I have an Asus G14 3060 Ti. You'll see 3 years now. Keyboard doesn't work. Well, that's not good. My computer's a lot older than that, though. My computer's like 8 years old or so. Found a math academy in Japan. I mean, that sounds pretty sweet, not gonna lie. Any excuse to live in Japan. Thank you, Anshu. Honestly, my physics, I I wish I was better at physics than I am, but I know some physics at least. I know kung fu. Okay, so that's the first part of problem 3. Let's do the same thing with translating my hectic office hours notes for the last part. Just like the very last sentence here. And then we still need to do the middle part. I think it's going to be the same as the first part, nearly, but... You know zero physics? Well, hey, you might end up like color cone and like the math that you're studying gets used in physics, so you kind of like learn a bit of it through osmosis. The Wheeler textbook on gravity. Wheeler gravity. I'm not opposed. So you automatically put the book under your pillow? That's a great system, Slim. Hope you're doing well. Why you guys sponge like in the air instead of using your legs, hips, and your entire body weight to deliver the punch? Did not really go to karate school because my dad said no. It's in a street fighting, you find giving the punch using your entire body. Do we only use our arms? I've never had that impression. I thought, I mean, what you're saying I thought was the proper way. Like you should you put your like shoulder into it. From differential geometry and Yang Mills. Fair enough. Yeah, it's like a spell book. Oh, it does. Yeah. This the way the lines are broken up looks like a poem. We dedicate this book to our fellow citizens who, for love of truth, take from their own wants by taxes and gifts. And now then send forth one of themselves as dedicated servant to forward the search into the mysteries and marvelous simplicities of this strange, beautiful universe, our home. Yeah, I'm looking for the contents. Yeah, I couldn't tell you, Suas. I'm not an expert on fighting. I've never been in a fight. I've been slapped once. And one of my great regrets in life is not hitting back. But that's the closest thing to a fight that I've been in. The Parable of the Apple. So, okay, this thing starts off with tensors. Differential forms. Ooh. Wow, this is a lot of time spent on flat space-time. It looks pretty cool, though. Differential topology? I didn't know that was a thing. Oh god. I can already tell where we're gonna fall off the rails again if we do this. I'm down to try and to fall off the rails, though. Riemannian geometry? Wow. This is really... This gets deep. Oh my god, it's still going! This thing is a mod. Oh my god! How 27 chapters? We're almost there. We're at Frontiers. Oh my god, 44 chapters. LG Suez, I'm sorry. Okay, let me catch up with chat. Have I ever been contacted to sell my soul? IBM, Microsoft, Quant? No, I have not had... I haven't jumped into it in a long time, and I had terrible luck. People... I couldn't sell my soul if I wanted to. I also don't want to, but... Been punched on 3 different occasions. They were kind of fights, but you didn't land any punches. Aw. Feel like I know how to fight. I fear I'll end up killing people because I have a dark thought of how to hurt people I'm about to fight. Probably best not to fight then. Hi Lothric, hope you're doing well. What you caught me doing here in this moment was looking through a book about general relativity that Femvox is interested in reading, which I might also be interested in reading. Not all 44 chapters, but maybe we'll see how far we can get. So I was just looking through the table of contents, and then I'm about to switch back to doing homework unless I get distracted like I often do. Might as well read Do Carmo. I don't know what that is. It's so what's the book's about general relativity. Fenbook Slim wants to read too. Don Slim and Fembox will be the new mathematical holy trinity. That will be fun. The Unstoppable Team. 1305. Imagine printing that. I know that thing. That's we like a phone book. You can read that one too. Maybe it goes against my motto of not doing useful math. Not a fighter or a lover. Yeah, exactly. I did not see it. We can read it. Like there are more pure things that I'd be interested in reading too, like measure theory, graph theory. I forget what else I was saying. Resonant Caliday? No, I've heard of it on Shu. I haven't read it though. I think Femlox has read some of it. Oh, this is the Do Carmo book. $511 pages. Okay, that's under half. It was good that stream with Color Cone. I don't have super chat unlocked, Suhas. My YouTube channel isn't big enough. I appreciate the thought though. Thank you. Yeah, no, I learned that you can take derivatives of things that, in a sense, that I didn't know you could take derivatives, like Heaviside function or absolute value. 3 blue, 1 brown. I assume it's just gonna be on his like website. Aerodov is a toughest book to understand in physics. Maybe I couldn't tell you. I've definitely heard of Aerodov. A short on the website. On the YouTube. Oh, okay. How big should it be? I forget. Let me see. It's the watch hours that have always been the problem for YouTube for me. Okay. If I want to have memberships and I guess super chats, I add the subs. I'm not even close to the watch hours. And if I want to earn money from ads, it's even more watch hours. I used to be closer, but since I used to have like 1,500, I think. But once I went to grad school, I couldn't stream as much, so. I'd never been close, though. Oh, that makes sense. Once you have like one video blow up, that could be enough. Live streams do count. That's the only source of... or I mean, it's not the only source, but it's the main source of watch hours that I get. Yeah, 3 blue 1 brown is great. I generally do not like chemistry on Shu. I've only ever taken general chemistry. That's like a first year university class. That's as far as I've gone. Maybe there's some niche further in chemistry that I would like, but so far I haven't. Oh yeah, Fitvox, thank you if you do. No worries, because like I'm just kind of gonna let it happen if it happens, and I'm not worrying too much about it, but it does help if you do lurk. How in chess there are IMs that are strong as GMs. That's the case for 3B1B. It's probably the most well-versed undergrad in the math world. Yeah, true. That's a good like metaphor. like Gotham Chess. He's an IM, but he's a huge content creator. That's true, Slim. Maybe. Yeah, like I might like physical chemistry. I remember my chem major roommate really complained about physical chem, so my chest elo. um, on chess.com, it's like I'm a little under 1200, I think. I thought he was in a bachelor's, 3 blue 1 brown. Maybe I'm wrong. Huh. Can you always find disjoint disks that cover all 10 points? And they're fixed at radius 1. I don't know. I hear the first part again. I don't know. I this feels like we need to think about lattices or something. I would guess. I feel like it'd be yes. That's what my gut is telling me. Oh, see you, Raven. You can barely pass 600. How do you get better? I mean, I don't know. I studied chess as a kid, which gave me a big advantage. Nowadays, I watch Hikaru's YouTube channel. He's not super educational, but that's how I like pick up small things at least. But I just go to chess YouTube. Like John Bartholomew has a great channel to learn from. I used to watch him a lot. Whole chemistry is rote learning, valid reason to hate. Yeah, that's kind of my issue with chemistry. It's a lot of memorization. A poll? We could make a poll. I feel like just typing in chat is probably enough, though. um, I feel like that'd be better in like a bigger stream poll, but you think no? Yeah, Anshu, I dual stream to Twitch and YouTube, so I consider Twitch my primary like platform, to be honest. But the chat up there includes both chats. An unfriendly what would a hostile arrangement be? Like I'm thinking about like could we have equilateral triangle and one in the middle? And each of these are length 1? Is this possible? I don't know if on the border counts. That is maybe a vague part of the problem. Like, are they overlapping if the borders touch? Well, You, I mean, I guess you could do like you could put one of them like way far off. Yeah. Yeah, Jerusalem. Like that. Hmm. It needs using coordinates. Or I guess yeah, oh okay, yeah, yeah. Like yeah, I guess Anis and I have the same question then about the border. What do you put a dot, then move the distance x, then repeat that 3 times. X equals diameter. So you want 4 dots spaced one apart, Suhas? So I guess like almost what I've already drawn here, just one more. Think about the sphere packing problem to get ideas, maybe, yeah. Yeah, so I'm not sure if it should. I mean, well, no, because you could definitely do, like, you don't have to be centered. It is the thing. You could do this, I think, or something like that. Oh, you want them arranged in a square? I mean, a square would be even easier, I think. Because you can just make them as far away as you want. Like, you can just barely make them inside the, the circle if you wanted. Yeah, that's true. Um, a 4x4 grid. Yeah, I mean, that's going over the allowed number of points, but maybe you have a point where as the grid gets bigger, it's harder to, like, we just do a 3x3 grid. No, we can definitely do this. I mean, hmm. There's still like a border issue with this one in the middle. I mean, ugh. I bet you could get a circle that goes like this, though, couldn't you? What is that distance? No, that distance is too big. A circle like that does not exist. Oh wait, the circle is radius one. My bad. A circle like that. Like, I'm getting diameter and radius mixed up this entire time. Seven at vertices in center of a hexagon. Find a clever way to place the final 3. Ooh. It's an interesting thought. Okay, hexagon. Hmm. I guess the first question is like, should they be inside the hexagon or outside the hexagon? If these are all length 1, what are the diagonals? They're isosceles triangles. The diagonals are longer than 1, right? So we can center a circle in the middle one. It's still 1? The diagonals? Really? Wow. So does one big circle contain all these if you don't include the borders at least? Or like I don't know how we're counting the borders still. Maybe I should type the problem on the screen so people can see what we're talking about. This is a double negative. I haven't phrased this that well, but I think that's the gist of the question. You have a circle containing 3 points and 4 other circles containing the other points. Circles cannot be packed in a grid properly. They will have gaps if there's a dot inside those gaps. So, yeah, so I guess with that argument, you could make a 3x3 grid and just choose where to place that very last dot. This is a funny circle. Oh, this is where Penix is getting the hexagon from. Or I assume maybe Penix is... Oh yeah, Penix mentioned circle packing. So I assume this is where he got the idea. So could we place a dot in one of these gaps? And it wouldn't be possible? I don't know. The hexagon doesn't have to be length 1 either. I've been making it length 1, but... I guess for these circles, well... Imagine the plane pre-tiled right with circles. Put the dots down to make it impossible. Yeah, like take this and we can even remove the hexagon. No, I'm just not sure, Suhas. Like, I'm not sure if there's some other arrangement of circles that could save it. This definitely feels like the key thing to think about, though. What is this? Are these bubbles? Hmm. The little white archy regions are also hexagonally symmetric. Like you can fit a hexagon in there. A regular hexagon and... Okay. What if you rotate the grid? What will be inside the circles? I don't know. The centers are on a... Oh, okay, okay. So you could take the same hexagon and you could make its corners fall perfectly in the middle of these gaps. So yeah, I guess I agree with you too that the answer is probably no. Or I think the answer from chat has generally been no. I'm still like I'm not 100% behind it just because I like is the densest packing like in this image definitely the best for this problem, or is there some other arrangement of circles that could still save it? That's what I don't know. Yeah, Suhas, basically. This is trippy. Rhombit trihex? Snub trihex? Geometry is wild. Skew quad sounds like a workout. ISO trap? Right, Suhas. I know you can't close the gap. Oh yeah, a bounded domain, would that be an easier problem? I assume it would be. Because you can just put one dot like way up in a corner. Well, that'd be cheating, but I mean I don't know if it's cheating or not, but I bet a bounded domain would be an easier problem. Yeah, so it's, I'm just worried that like I know like Apple always exists, but we don't have to pack them as closely as possible. Like the problem has a little more flexibility than that. That's why I'm not sure. Kind of my dad's Martin Gardner books is what made me fall in love with math in the first place. Oh, cool. That's a cool looking fractal. Martin Gardner. I feel like you've mentioned him before. Oh, see, yeah, the Wikipedia page is purple. When as one of the 100 most influential magicians of the 20th century, that's a really specific list. Triangle with dot in the middle doesn't work because uh you can make a circle like that and a circle like that and that. Polyominoes. Hexaflexagons. Had problems learning calculus and never took a mathematics course after high school. Wow. Okay, anyway. Maybe we can force the dense packing for 7 circles. Yeah, okay, that's a good strategy. Aeneas, like, do these dots in a hexagon force that? I mean, that could already be true. Like, Felix may have already found the best arrangement a while ago. So if I really wish okay, I wonder if the YouTube comments for that has clarity about the borders of the circle. Because if I draw a circle centered on the center, it's going to touch the other points. Where's my YouTube watch history? Here it is. Comments. Let's see what the reply is. Solution here is very beautiful, a bit out of left field. Hmm. With enough points is impossible, just sign the choice of the number 10 is not arbitrary, which is terrifying. I don't see other people complaining about whether the boundary of the circles count or not. Hmm. Okay, well, oh well. Yeah, we could make it slightly bigger or smaller than 1. That's true. I mean, we might not be able to, though. So the circles are a radius 1, and that might say something about how big the hexagon should be. I mean, I don't personally care about spoilers at all, to be honest. If I'd be just as happy with this problem if I read the answer key. Yeah, I think it's probably a better problem if boundary intersection is allowed, as you say. But then how do we... Aren't we already done with this then? Because, like, well, I guess we don't have to center it. We could... We could draw a circle like this. I don't know if a circle like that exists up there. I don't know. I mean, so it's just about like whether overlapping counts, whether touching counts as overlapping or not. I'm just reason opposed to reading answer keys. I, I'm not into math as a. I'm not into this type of math for its own sake. That's why I'm okay with reading the answer key, I guess. Like, this isn't the part of math that I like particularly enjoy, but this is like I think what most people, if they say that they like math, this is the type of problem that most people would think of. No, I mean, you I don't think it's unreasonable for you to not want to read the answer key. In the same way, like a Sudoku will be boring if you just immediately read what the answer is. If this is like this is the same thing as doing a Sudoku, I think. Are you possibly fitting 2 dots into one circle if the distance between the 2 dots is 1? It's the circles are radius 1, I think, not diameter 1. Unless I'm misremembering that. Oh, yeah. No worries, sue us. Yeah, so I might switch back to doing PDEs in a minute here, but this feels like the idea, but the comment from 3 Blue 1 Brown saying the answer is out of left field makes me worried that this circle packing thing isn't the right thing. Like, what would be a left field thing? I don't know. We can't, as far as I know, we can't model to the PDE, so not my problem. Literally. Wonder how many people wasted how much time on this problem. I mean, waste is a matter of opinion. I bet a lot of people have spent a lot of time on this problem, though. Even if I don't like that part of math, I do respect that it's useful to do it. I just don't want to be the one who does it. Basically. Wait. You don't belong here. My snipping tool. Hey, Syntax. How's it going? What do you like about math, and what do you dislike about that type of math? What I like about math is solving a real world problem with it. Or somehow doing something that feels directly, tangibly useful to people. Like, I like the feeling of helping people. That's why I do this stream, because I like helping people. And so what I dislike about that type of math is I just don't see the point in doing it for myself. like my first question with that type of like circle problem is like, why should I care? And probably has a reason to care, but like if I investigated every problem like that super deeply, I wouldn't have time to do the types of math that I enjoy. Fuck a real world application, we do number theory in this bitch. I mean, cryptography would like a word, but yeah. I do like to harp on number theory as like it's usually one of the fields where the people who like number theory really don't like their math being applied. And the other area I think is like abstract algebra. You love methamphetamine? I mean, you live your life. I'm not here to judge. Number 3 is the queen of math. I know. Someone important said that. Gauss, I think. I just can't get into it though. I don't know what to tell you. Mathematics? Yeah, sure, Suhas. You use TTS? Or speech to text? Sure, sure. You definitely didn't just out yourself there. You know, and I think it's possible to have room in your heart to love both mathematics, and methamphetamine. It was Gauss? Okay. I guess, or it's Gauss. You guess, or one might say you Gauss. That's true. You might Gauss. Cryptography aside, yeah, I assume that number theory. I guess I guess the other big use for, I don't know if number theory has another use outside of math. It definitely is helpful for like abstract algebra, and that could be helpful for other things. That will be the day, Femvox. I mean, I did do that one session with Slim where he like taught me a thing or two about number theory. He did offer to do more, and I didn't take him up on it because I forget when, but I think I was going off to grad school sooner or later. Allegedly, Erdish also liked Beth. That's true, or that's my understanding too. Aeneas. Queen theory is the mathematics of numbers. Those are the exact words. Fair enough. Smell of, oh yeah, fresh ground coffee. I mean, okay, is there anything better than waking up to the smell of like coffee and breakfast cooking? That's something that'll get me out of bed. Friedrich is spelled Fried plus rich. Fried plus rich? Comrade Gauss? Wait. I'm missing something there. Oh, fried. Oh, eat the rich. I get it. Comrade Gauss. Waking up next to the love of your life? That'd be a nice feeling. Hopefully one day. What am I doing with this? Oh yeah, we're, oh wait, this is dt, that's dx. We Fubini. And we don't need to do anything overly difficult to Fubini this, because the bounds are just constants. I always had in my head that it was, oh, F-R-E-I-D. Doesn't make sense, it should be I then E. I wouldn't know. Yeah, I could see it going either way. Also, Karl Gauss, Karl Marx, coincidence? I think not. Wait, what problem am I doing? Oh yeah, I'm doing the third part of the problem. Okay. Gaussian blur. Yep. Now he's cooking. Is there a neat way to compute a Jordan block to the power of n? Some funny stuff with binomial. Ooh. That's a fun question. So yeah, Jordan blocks specifically are not going to have nice eigenvalue decomposition, right? Oh, sorry, so it's like the problem I was just working on, or the Jordan matrix that I'm looking at now. Distribution, not coefficients. Could be. Oh, the meaning of life. Pizza. That's the meaning of life. As I plus n. Oh, yeah. There's the binomial part, right? Why the hell is pizza so funny? Yeah, I think that. Well, there's your answer. All right, good call, Aeneas. Hey Skirtle, what's your answer, Suhas? I wonder, would it be slightly cleaner if we factored the lambda out? I don't know. What is it? M choose n. Wait, aren't these lambdas canceling? Did I make an error somewhere? Oh, it's to the n. There we go. That makes more sense. Uh, chemistry that somehow learned to create bad copies of itself, bad copies which have natural advantages outcompeted the good ones. Efficient machines that convert chemical energy into heat. You think fire is more efficient. That's the meaning of life? That's another answer. Purple lights. I respect it. N to the power of something. Is there a nice way to compute it? Does it just shift the ones or something? Maybe. N to the m is in fact easy, since for a Jordan block, n is just ones. You don't have to take the lambda out. I was just thinking it might make the formula simpler. Maybe the fortune cookie is right. It does look kind of pink. I think because it's too bright out. I think it looks more purpley when it's darker. It's getting all like washed out. Compute diagonals. Okay, I think I need to see an example of this. Well, let's square this matrix. Okay, we do that times that is 0. That times that is 0. That times that is 1. That times that. Well, okay, wait. Let's do this smart. That's a column of zeros. So these are both zeros. This is a row of zeros. So those are zeros. That. Wait, I already did that one. That times that is 0. That times that is 0. A mirror reflects a man's face, but what he is really like is shown by the kind of friends he chooses. I guess so. I don't know. Just a shift up. Yeah, I kind of want to. Maybe we can make Wolfram Alpha do the higher powers for us. If we keep multiplying that, I wonder what happens too. But I think it's Wolfram Alpha time. Easy proof of the partial matrices? Maybe. Just maybe. Alright, Wolfram Alpha, it's time for you to suffer. Square it. Okay, it shifts the diagonal up by 1. Cube it. Shifts up by 1 again. Ooh. And then it zeroes out. That's wild. That, yeah, I feel like you could do an induction. I feel like it, since that's the behavior. Well, I guess with induction, I'm thinking of like for bigger matrices. Once you already know the behavior, I guess. I don't know. First life is to replace humans with fire. Maybe Suhas. You know, Skirtle, and maybe that's the way. Hmm. That's a pretty neat question, though, syntax. Hey, okie dokie. Artichoke. Okay, what's going on with this? It's going pretty good. Just as usual, suffering through this one homework for a difficult class. But I did get some help on it from office hours this morning, so I'm kind of going through the notes that I took during those office hours and trying to like write them out again and solve the problem. Yeah, I know it looks complicated. Sorry. How are you doing though? Here's a neat problem I solved this week. Ooh. I'm your co-conspirator? Damn. I got baited. Your name is how you're doing. That's fair enough. Okie dokie. I don't know if this is helpful. I want to know what this becomes when you FOIL it out. Uh... That's helpful. Okay. And we know this is 1. And we know this is 11 over 36. So question becomes, what is this? Just kind of messing around with it. Well, do we want to factor out a cosine squared also? I don't know. Most mathematically efficient way of creating a wildfire? I feel like I need to start pleading the fifth. Hmm. I guess cosine squared is 1 minus sine squared. Ooh! Oh! Is this... am I cooking? Oh no, it's minus. I'm not cooking. I am cooking? Oh, because I bring the sine squared back in. Okay, so maybe that wasn't necessary. Oh no, wait, I don't bring it back in. Mm. Okay, sue us. Uh... Oh, you know what? I could say... sine squared x, sine to the 8th x, sine to the 10 is 11 over 36 minus cosine to the 10? Oh wait, this isn't gonna cancel like I was hoping it would. Maybe it still leads somewhere nice, though. Hmm. I like watching with our eyes. I don't know. That's probably your speech to text. Simply waiting is the most energy efficient way of creating a wildfire? True. Uh... This feels like the wrong direction. Called sum product recurrence? Oh. But I think anything just like letting random chance for a fire to start just spontaneously makes you use the least energy. You might be waiting for a long time, but some product recurrence. Okay, well, if it's something you've never heard of, then I probably haven't heard of it either. Let's just Google it. I'm ready to read the answer key. Ugh. Uh, I assume this is the important thing, to make it a polynomial of some kind. So maybe we just want everything in terms of signs, and then to treat it like a polynomial. Oops. How do we know what it's equal to, though? Hmm. The idea of factoring out both sine and cosine. Really? Hmm. I don't know what to do with this, though. Now it just feels stuck. Hmm. In terms of eighth powers, sure. I don't think I know anything about the eighth powers. Do I? Hmm. Oh, we can keep on repeating this. Uh, okay. So I would do the same thing. To the 8x goes into the 10x. Okay. And I assume this is where you can have a trick to shorten this if you're clever. um. 11 over 36? I mean, if I want to repeat the process, I need to multiply the 11 over 36 by the sine squared cosine squared, which I guess we can do. The fourth x plus cosine to the 6x 11 over 36. I guess. Let's see where this ends us up. I think I'm the weird one that I don't seek out problems like this. Sine to the 8th. I'm just gonna mentally multiply that by sine squared plus cosine squared. Sine to the 6. I should really abbreviate these with just S and C. There better be a cancellation at some point here. So sine to the 8th plus cosine to the 8th. Hopefully we have that. Oh god. It's equal to that? Is that the substitution that I want to do? Oh. I'd rather it be simpler. I don't know, Suas. Just you letting your mind wander, I guess. Okay, this is becoming a lot more algebra than I want to do, Fembox. I'm sorry. Also, I'm not quite sure, like, I'm not sure exactly how to deal with the 8th powers here. Ooh. Hey, Winklebot. The original problem is if you're given sine to the 10 plus cosine to the 10 is 11 over 36, what is sine to the 12th plus cosine to the 12th? I don't know, Suhas. 42, I like it. Qualia is not real. According to Fox, I have a good like first step here with taking sine to the 10 plus cosine to the 10, multiplying by sine squared plus cosine squared. But then there's like a whole rabbit hole, like algebra and substitutions that you have to do that I kind of don't want to do. I'm thinking about just calling it anyway. because I'm getting tired and I want to be able to focus on homework. But I'll wait to see what you're gonna say. When I convert sine squared to 1 minus cosine squared, I tried that originally and I didn't. I eventually got stuck and couldn't progress. I basically have the method. I mean, I'm a little stuck with the method. Because I don't want to deal with the sine to the eighth plus cosine to the eighth. Like, substituting this doesn't seem productive, but maybe it is. I'm building it top down. Or yeah, like we're going from higher powers to lower powers, but I don't know. Oh, you built it from the ground up? Interesting. Maybe that's why I'm not seeing it. Maybe I should do it from the ground up. But I don't want to do it right now. I guess you would start with sine squared plus cosine squared equals 1 and just start squaring it. Oh yeah, it's that right there is the OG. That's what you did. That's probably a lot more direct. I do think I'm gonna. Okay, you got it. I do think I'm gonna call it for the day there then. Oh, I think the music just stopped anyway. Oh no, it didn't. It's just quiet. Yeah, it's an interesting one. Little brain teaser. Okay, YouTube stream will get cut off here on Twitch. We'll look for a raid. So sue us, anyone who's here on YouTube. Thanks for being here.